Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is find the maximum number of fruits collected. The problem category is of hard level, but after watching this video and understanding the problem and the solution approach, you will be able to solve this problem very easily. The given input in the problem is a n by n 2D array of integers. So there is a array which is a two-dimensional array, and the dimensions of this array is n by n. So basically the number of rows and the number of columns in the 2D array are same. The output we need to give is the maximum number of fruits three children's, let us say the children's are A, B and C. So maximum fruits three children's can collect. Every data in this n by n matrix is representing the number of fruits at that particular point. Now let me try to explain you the whole problem using an example, and the solution approach and everything will be explained using just one example. Let us assume that we are given this n by n 2D array, and this is our 2D array. The array is of size 5 by 5. There are 5 rows and there are 5 columns. At every block of data, we are given an integer, right? You can see the integers are like 10, 7, 18, 14. These are different integers given to us in our 2D array. Every integer in every block is representing the number of fruits which is kept at that particular block. That is, in this particular block, we have 16 fruits. In this particular block, we have 0 number of fruits. In this particular block, we have 13 fruits. Now, if I come back to the output we need to give, we need to find the maximum number of fruits we can collect. Basically, there are three children, A, B and C, and they will collect the fruits. We need to find the maximum fruits these three children can collect. Now let me give you the scenario of this problem first. So we are given a two-dimensional array, right? And there are three children, A, B and C. The child A is at the position 0th row and 0th column. Basically this particular block. So at this block, the child A is there. At this particular block, which is at 0th row and 4th column, basically the first row and the last column, at this particular block, the child B is there. At the first row and first column block, the child A is there. And at the first column and the last row block, we have the child C. So there are three children, A, then B, then C. The goal of all these three children are to reach to the last column and last row block, which is this one. All the three children want to reach to this particular block, which is the last one, the last row and last column. Our focus will be to move these three children to their target block, and while moving, they will move through the grids or the blocks. They cannot move from outside and reach to this particular block. They will have to move through these blocks which are already given in our array. For example, if you want to move this particular A child to the target block, then you cannot move it directly from outside. You will have to move through the array and you will have to reach to this particular block. The question says that while moving from each block, the children are going to collect the fruits. So the thing is, if there is a child A who is at the first row and first column block, it means that the child A is having 16 fruits as of now. Now, if the child A moves down, they will collect the 3 fruits, and at this point, this particular block will be empty. But the children A will have 16 plus 3, 19 fruits. Then maybe it can move in the diagonal and it can collect the 18 fruits. Then it can move and finally reach the target. Our goal is to move all these three children in the final block, and while moving, they will collect fruits, right? We just need to return the number of fruits collected by all these three children while moving towards the final block and finally reaching to the final block. And we need to maximize the number of fruits collected. So we need to move these three children in such a way, in such a directions, through such blocks, so that finally when they all three meet at this particular block, they will have collected the maximum number of fruits. Now there is another rule that no children, either A, B or C, can move more than n minus 1 times, where n is the value of number of rows or number of columns. Both are same. So if we have 5 rows and 5 columns, so the value of n is going to be 5. No children can move more than 4 times. That's the rule. They cannot move more than n minus 1 times. And every child A, B and C have their own directions defined. The child A can either move down or go to right or move in the diagonal. It cannot go up, it cannot go in the left, it cannot go diagonally back. Now let's focus on each of the child one by one, and let us try to understand the problem step by step. If we talk about the children A, and if we move this child A towards the target, let us say that this is our target, right? If this is our target, the target is for all the children A, B and C. And we know that no child can move more than n minus 1 times. Now the options for child A is to move down, move right and move in the diagonal. The thing is, the child A, although it is allowed to move down and in the right, it will never move in the right or in the down direction. Reason being, it can only move n minus 1 times and it needs to reach to the target block. Let us say this child moves down. Now it is at this position and it has moved 1 times. It is allowed to move a total of 4 times, right? N minus 1 times. Now, if this child moves in the right side, it will be at this particular position. If this child moves in the down side, it will be at this position, and it moves in the diagonal, it will be at this position. Let us say it moves in the diagonal and it reaches to this particular position. Now it has utilized 2 moves, right? Even if it moves diagonally 2 more times, it will reach at this position and it will not be able to reach to the final target position. See, the thing is, for the children A, which is at the first row and first column, or 0th row and 0th column, it needs to move to the 4th row and 4th column. It is only allowed 4 moves. So anytime if the child A moves down or in the right side, it is only changing either its row or its column, but it is utilizing one move and it cannot do it. Reason being, finally it needs to reach to the final one. So if you focus here, if the initial row is 0, initial column is 0, and the final row is 4, final column is 4, only number of moves allowed are 4, then every time it has to move through the columns and through the rows, that is diagonally. That is from 0 0 it will move to 1 1, then 2 2, then 3 3, then 4 4. That should be its ideal move. So this particular child moves are fixed. Although it can move in the down and right direction, it cannot move. It should not move. Reason being, it is allowed just 4 moves. That is n minus 1 number of moves. So the path of the child A is fixed. We don't need to worry about child A because the path is fixed. It will keep moving in the diagonals and then it will reach to the target position in 1, 2, 3, 4. 4 moves, right? So let me do one thing. Let me mark the diagonal positions particularly for the child A, right? These are the moves for the children A. Now let's focus on the other childs, the child B and the child C. See, the thing is, the question says that if a particular child moves through the same block, let us say if I try to move this particular child, and for the child B, the allowed moves are, it can move downwards, it can move in the left diagonal, it can move in the right diagonal. These are the allowed moves. That is, the row of the child B will always change anytime it will move. It is in the 0th row, it will move and it will go to the first row. It will definitely go to the first row every time it moves. From the first row, it will definitely go to the second row. The row will change, but the column, which is 4 as of now, can be 3, which is this one, can be 4 itself, or can be 5 if 5 would have been allowed. 5 is outside of the range, so it is not allowed. So when the child B will move, it will move in a different row. It will go to the next row every time. But the columns, it can go in the left column, it can stay in the same column, and it can go in the right column as well if that right column would have been allowed. For example, if the child is at this point, I can move it in the left side or downwards or right side diagonal. Now the thing is, guys, the question says that if any child moves through a block, let us say if 2 or more child moves through the same block, then only one of them can collect the fruit. If A has moved through these blocks, the diagonal blocks, and it will collect the fruits, right? Then if B will also move through the same block, then this particular block is empty. It is not filled. So although B can move through the block to reach to the destination, B cannot collect fruit from this block because it is already collected by A. So now let us completely focus on B and try to move this B to the target block. Now the thing is, for the child B also, the number of allowed moves are 4. That is n minus 1 moves. N is 5 because we have 5 rows and 5 columns. Let's focus on the maths here. Right now B is at the position 0th row and 4th column, right? B wants to reach to the 4th row and 4th column in 4 moves, right? Here you will see that we just need to change the row number, right? To change the row number every time in every move, you will finally reach to this particular block, 4 by 4, or the final target block. Now, this says that I can move this B not only in the downward direction every time, like one of my move can be if I just keep moving downwards, right? If I keep moving downwards, 1, 2, 3, 4, I will take 4 moves and I will reach to the final target. But there is no restriction for B as it was for A. B can also go in the left diagonal, come back to the right diagonal, go down, and then finally reach to the final target. And it will be 1, 2, 3, 4 moves only. Reason being, B can move in the left diagonal and then come back to the right diagonal, which will be equal to B moving downwards and downwards. We can reach from this particular block to this particular block in 2 moves, but following different path. But there is a catch. Let us say I keep decreasing the column for B while moving. If I move in the left diagonal, then if I move in the left diagonal, now I can move in the right diagonal and move in the right diagonal. It will take 1, 2, 3, 4. 4 moves and it can reach to the target. Although we will not be able to collect the fruits, reason being A has already collected the fruit. Because we are assuming that A has just one path, so let A collect all the fruits in that particular path, in the diagonal. Because we ultimately need to find out how many fruits A, B and C can collectively collect. So we don't care if A collects or B collects. So for us it is easy that if A has one path, let's give A the complete diagonal. But B can go through the diagonal and it can reach to the target but cannot collect the fruit. But there is a catch. B can keep moving in the left diagonal, right? But if I move it 3 times in the left diagonal, now I cannot come back to this particular position in 4 moves. I have used 1, 2, 3, 3 moves, right? Now if I go in the right diagonal, I will still be 2 places apart or 2 grids apart from my target. So this tells me that although B can go through the diagonal, that is B can go through these elements by moving left diagonal and left diagonal, B should not move through the diagonal and come in the lower side. That is the lower side of the diagonal. B should not go through the lower side of the diagonal because now it cannot come back and reach to the target. So what I can say is B should focus on moving through these blocks which are upper diagonal side. That is all the blocks which are over the diagonal. These blocks B can concentrate and B can move along. B can go through this, then it can go through this, then it can go down and come down. Or more, what B can do is it can go down, go in the left, go in the right and then come down. But every time you will see that to reach to the target block, B should only concentrate on the upper diagonal side. It should not try to come to the lower diagonal side because now it cannot come back to the target. because to come to the lower diagonal side, it will have to take like 1, then 2, then 3 moves, right? Now, if it wants to come to the final target, it needs at least 2 moves, 1 and 2. But it has just 4 allowed moves, 1, 2, 3, 4, 5. 5 moves are used. Reason being, it is in the lower diagonal side. And similarly, if I talk about C, what will happen? The moves for C are, the columns will always change for C. If it is at this position and if it want to move, it can go in the upper diagonal side, in the right side, or in the lower right diagonal. These are the 3 moves allowed for C. C is at this position, it can move to 8, 14, or at this block if this block would have been there. For example, if C is at 8, now C can go to 8, go to 5, go to 8. That is, the column will always change for C. The rows can decrease or can be same or can increase. These are the movements allowed for A, B and C. Now don't try to overcomplicate your thoughts. It is very easy to understand, right? If A is there, it can go down, right and diagonal. But the number of moves allowed are n-1, so it will always go through the diagonals. If B is there, it can go down, left diagonal and right diagonal. It can try to go through all the ways, but it should not focus to go beyond this particular diagonal, right, in the lower side. And similarly for C, it can go up diagonal, then it can go up diagonal. It should not try to reach to the upper diagonal side. Reason being, if it reaches to the upper diagonal side, now it has to go down, right, to reach to the target. But the number of moves allowed are just n-1. So what we can think from here is, for A, the path is the complete diagonal. For B, the path will be the upper side of the diagonal. And the thing is, for B, the path can be the diagonal as well, and it can still reach to the target within the allowed number of moves. But the thing is, we need to maximize the number of fruits. The diagonals are already being collected by A. So for B and for C, although the diagonals are allowed, they can go through the diagonals and reach here. Like for C, I can go 1 move, 1 move, 1 move and 1 move. Total 1, 2, 3, 4 moves, and I can still reach to the target. But let's not do this. Reason being, it's already been collected by A. So let A focus on the diagonals, let B focus on the upper side of the diagonal, let C focus on the lower side of the diagonal. And now we have 3 separate questions. How to collect the diagonals? Simply we can just run a loop and fetch the diagonal elements and take the sum. And what will happen? We will find out how many fruits A can collect. What about B and what about C? Now for B and C, the process is a bit complex. Try to focus on everything I am explaining and you will find it easy to understand. First of all, you should understand that B will always start at this particular point. So B will collect the fruits at this particular point, which is the first row and the last column. But what should be the next move for B? It can only move downwards or in the left hand side or in the right side diagonal. We will try for all the 3 moves. But the thing is, although this particular block is allowed for B because it is the upper part of the diagonal, B will not be able to reach to this particular block. Now what we can do is, we need to try to understand that we don't know that B should move to the left diagonal or downwards or right diagonal. We don't know about this. Maybe B should move to this diagonal because it is 14 and it is highest, right? But later on, we may find that, okay, if I choose this particular block, the later values which are allowed where I can move are very low, or the number of fruits at those blocks are very less. So the thing is, although this 14 seems to be the best answer, the best way to go after this 14, it may not be the global solution. It may not be the best solution while reaching to this point. Reason being, if this would have been a bigger block, let us say 100 by 100 grid, then after reaching this point, we would have 1, 2 and 3 positions, right, to move. But what if I reach to this particular position 13, which is less than 14, but now I have this down, then down and then right diagonal, these 3 positions, right? If I move to 13, I have one more position to choose from. If I move to 14, I have these positions to choose from. Maybe, I don't know, right? Maybe the input says that at this point, the value is 1000. And at these points, the values are 1, 2, 3, 4, 5. But we can miss out this particular value, right? As of now, it is a part of the diagonal, but imagine a 100 by 100 grid. Then this particular value would have been allowed, right? Because the diagonal would have been lower. Now, this tells me that I cannot just greedily select, I cannot just be greedy and select the next best element. Selecting the next best element can give me the solution at this particular block or at the next row, but not the global solution while reaching to the target. So what we have to think is, we have to try all the path. Let's try for this path and then let's try to find out while reaching here what should be the best answer. Or let us try this path and let's just try to find out while reaching here what should be the best answer, or the best number of fruits or the highest number of fruits we can collect. Now, instead of focusing top down, that is from source to target, let us focus from target to source. That if I just track back, what should be my ideal position? See, the thing is, if you want to reach this block, you will either be coming up from here or from at this point or at this point, right? Now this is not valid, so let us ignore it. This is the part of the diagonal, right? If this is the part of the diagonal, then we should ignore this. Reason being, I will not focus on diagonals for B. I will never move through the diagonals for B because this is going to give me 0 points always, right? What about this? Now this is the only place or the only block from where I can come to this target block. So now I am sure that I have to travel through this particular block. This should be my way if I want to reach to the target. Now, if you want to reach to this, because this is your target now, then again you have 3 options. 1, 2, and 3, right? Our goal is that we keep tracking back and we reach to this particular point. Now our source and target are reversed, but now you can see that we are able to build the answer. We have no confusion as of now. Now, if I want to reach to this block, from where should I come? Should I come from this block or this block or this block? But again, the question is same. If I come from this block, maybe while tracking back, I may miss out a path, which is actually the best optimal path, which can collect the maximum number of fruits. So now, from here, what I understand is we have to use dynamic programming. That is, we have to store our result at each point, because even if I try from source to target or from target to source, I have the same question, that where should I move next or from where should I come. I have to travel through all the paths possible, and this suggests us that let's use the dynamic programming to store the answers at each point. See, the thing is, if I know that if I'm at this particular point, and if I know that coming from this point can give me the highest value, or coming from this point can give me the highest value, then I may choose which particular path I should be coming from. But right now, these are the blocks values. If I could have something which can tell me that what should be the value if you want to reach to this particular point from 14, what's the highest or what's the best data you can have, or what's the highest number of fruits you can have. If I know this at each point, then I can select the best optimal path. So what we can do is we can actually create another grid specifically for B that is going to store the answers for B at every point. That if your B will pass through, let us say, this block, then at this block, up to this block, what's the maximum number of fruits has B collected. Now let us imagine you have that two-dimensional array and you are starting at this point again. If B is at this point, 14 is the highest because that's my initial point. Now from this point, I can reach to the two blocks. These are the two blocks I can reach. So in my DP array, I will just update these two blocks. Now, if I try to go to this block coming from 14, I will have a total of 27 fruits. But if I choose this particular block, I will have 14 plus 14, which is 28 fruits. I cannot reach to this block. So at this block and other blocks, the values initially are going to be 0. So now this is 27, this is 28. Let's actually update this, right? So this is 27 and this is 28, right? Now I can be coming from this block, I can be coming from this block, because these are local solutions up to this particular row. These are not the global solutions. So I will have to travel through all the blocks and see what's the best answer. Now, if I am at this particular block, I may travel down. I can travel to the left diagonal. I can go to the down or the right diagonal. I will not go in the left because this is the actual diagonal for my whole array. So I will not go through this block. Although, if these are my two positions where I can reach from 14, then my next positions where I can reach are these three blocks, right? From 27, I can go to 8, 7, and 18. From 28, we can go to 7, 18, and a block which is outside of our range. So the number of blocks we can actually reach are 3 blocks we can reach from these 2 points. But we will ignore the diagonals. But at this point, you will have to understand a pattern that for the first row, you will process 1 data. For the second row, you will process 2 data. For the third row, you will process 3 data. For the fourth row, you will process 4 data. But you will ignore those points which are not required. For example, if you can process these 3 data because you can reach these 3 blocks from 27 and 28, I will not go through the diagonals or lower diagonals, right? I will stay above the diagonals. So from 27, if I go to 7 or 18, the points or the fruits are going to be 27 plus 7 is 34. But I can actually come to say 7 from 28 as well, right? So 28 plus 7 will be 35. So to reach to this point, I have two paths, 14, then this particular block, then this particular block. The total points are going to be 34. Now, to calculate the total points, I don't have to trace back. I just have to look above, just my previous data, previous index, 27, right? At this block, I can come from here, I can come from here. I will actually want to come from this particular point because it will give me more number of fruits. So the highest number of fruits at this point is going to be 35. There are two options. It can be 27 plus 7, which is 34, 28 plus 7, which is 35. We will choose the highest one. And similarly for this, at this block, we can come from here or this point or this point. This is outside of the range. Let's ignore it. But if we come at this block from this block, the total point will be 27 plus 18, which is 45. We can also come to this block from here. So we are going to say 28 plus 18, which is 46, right? So at this block, the total amount will be 46. Similarly, now we will process the next set of data. See, the thing is we can reach to all these 4 blocks because our way can be 14, 27, 8 and 8, right? But we don't need to process the blocks which are down the diagonal or the diagonal itself. So we will only focus on this particular block. To reach to this particular block, where should you come from? Should you come from 35 to 5 or 46 to 5? You definitely want to choose 46 to 5 because that is highest. So at this point, my points will be, or the number of fruits will be 51. And similarly, to reach to this block, I will come from 51. So the total amount will be 52, right? So for the path of B, we should be fine, right? The thing is, finally, this B will reach from here to the final target and it will collect a total fruits of 52. And similarly for the C also, we will create another array of n by n. And what we are going to do is we are going to say that at this particular position, the value will be 0 because we are starting at this point. And then C can move only to the next 2 blocks, right? Either the right upper diagonal or the right point, right? These are the 2 blocks C can move. So when the C moves at this block, see, the thing is other values are still as of now going to be 0 for DP table of C. But when C moves to this block, it will have a total of 8 fruits. When C moves to this block, it will have a total of 14 fruits. Reason being, it initially had 0 fruits at the initial point. Now, when C has covered these 2 points, now C can move to from 8 to 8, from 8 to 5, from 8 to 8, right? Or C can move from 14 to 5 and from 14 to 8. It cannot move here, right? But the thing is, in the next 3 blocks, we are not going to process this one. Reason being, it is a diagonal and it will be the path for A. Talking about this block, it can come from this one, and this one, right? These are the 3 blocks from where I can reach to this 5. But the thing is, at this point, the value will be 0. Reason being, C can never reach here, right? So if you want to reach to 5, this will be 0. This is 8. This is 14. So 5 will ask this particular path that is coming from 14. And at this point, I can put the value as 19, which basically means that I can go from 0 to 14 and 14 to 5. The value is 19. Total number of fruits. But to reach to 8, which path should I follow? I will follow the path coming from 14, right? I can come from 8 to 8, but I will not follow that path because that will give me less number of fruits. So the total number of fruits at this point is going to be equal to 14 plus 8, which is 22. So now if I try to process the next set of data, the next set of data will be these 4 data where C can reach, basically C can reach to 27 as well. It can go here, then at this point, then at this point. But we are not going to process data which is at the diagonal or above it. So we just need to process this, and at this point we can come from 19, we can come from 22, we can come from this block. This is not valid, so let's leave this. 22 plus 1 is 23, 19 plus 1 is 20. We will obviously want to come from this particular path, right? So I can say that coming from this path, I will have a total of 23 fruits. So now finally what I can do is I can say that C will reach from 23 to 1, which will be 24. B will reach from 51 to 1, which will be 52. And A will follow all the diagonals. So A will be total 16 plus 0 is 16 plus 8, 24 plus 7, 31 plus 1, 32. So I have a 32 plus this 23 plus 1, which is 24, plus this 51 plus 1, which is 52. But you will see that we are counting 1, that is the final target, 3 times. For A, for B, for C. So let's minus it 2 times. So it will be minus 1 and minus 1. Because we are counting it 3 times, we just need to count it 1 time. So the total is going to be 32 plus 24 is 56, plus 52 is 108, minus 1 minus 2 is equal to 106. And that is going to be the final output for this particular data, for this particular input. This is the complete way we can solve this problem. And let me now jump back to the code editor and let me explain you the complete code for this particular problem. First of all, we are going to calculate the value of n, which is the length of fruits, that is the dimensions we have for our fruits 2D array. Then we are going to calculate the diagonal sum, basically the amount of fruit A can collect. So it will be for I in the range of n, we can select the fruits at row I and column I, and then take the sum. Now we are going to initialize a 2D array of the same size n by n with all the elements as 0 to calculate that when B will pass through that particular block, how much fruits it can have as max. Initially B is at the point 0th row and n minus 1 column, and at that point the number of fruits will be fruits of 0 and n minus 1. Now let's run a loop. We are going to run the loop for each of the rows because B will travel through each row one by one, right? But for columns, the range will be from n minus 1 to n minus 2 minus I, and it will be a reverse loop we are trying to run. And I will tell you the reason. B is trying to travel from this particular index, and every time it will come down, either in the left side, in the right diagonal, or down. So the row will always change for B. But what about the column? See, the thing is, B will initially cover the last column, then B will cover one more column than previous times it has covered. So it covers one column, now it will cover 2 columns, now it will cover 3 columns, now it will cover 4 columns. These are the columns B can travel through. B can even travel through this particular block. It can just go 1, 2 and 3, right? But it can never reach to 7 because even if it try to go as left as possible, reaching to 7 is not possible, right? From 8 it cannot go to 7 because every time the row will change. So we are having 1, then 2, then last 3, then last 4, all these blocks covered by B. So what we will run for columns for B is from n minus 1 to n minus 2 minus I, then minus 1. Also we are going to check if the value of j is more than I, then only we are going to process it. But we are going to process that particular element which is our target. Our target is when I and j is equal to n minus 1. So we are going to process the target block or all those blocks for which are upper diagonal, for which j is more than I. Then we are going to process the previous index from where you can reach to the current I, j index. The previous index will be I plus di, j plus dj. This di and dj can have 3 different values: minus 1, minus 1, minus 1, 0, minus 1, 1, which basically means that if you want to reach to this particular block, it can come from here or from this particular block. Basically this is minus 1, minus 1, this is minus 1, 0, this is minus 1, 1. Basically when I say minus 1, 1, it means that this is the previous row and this is the next column. For this is the previous row. The row is decreasing by 1. And if it is 28, from where we can reach to 35, then the row is still decreasing by 1, but the column is increasing by 1, right? So we are trying to trace back from where we can reach to I and j. That is going to be our previous index. And if that previous index is within the range of n, then in that case, the DP table for B will be updated for I, j, which will be the maximum of the current value. And you talk about the previous index plus the current fruit you can collect. So this will fill the DP table for B. Similarly for C, we will create a DP table and initialize it from row number n minus 1 and column number 0. Then we are going to run a loop. But for C, The columns are every time going to change. So for j in the range of n and for I in the range of n minus 1, n minus 2 minus j n minus 1. Similarly, what we did for p, but this time the rows and columns will be just the opposite case for c. And the logic will still remain the same. We are going to check the condition that we are only processing the lower block and the final target block. And for di comma dj in the previous indexes from where we can reach to the index I comma j, it will be minus 1 comma minus 1, 0 comma minus 1 and 1 comma minus 1. And then we are going to calculate the previous indexes. If the previous indexes are within the range of n, then we are going to update the value at dp table at index I comma j, which will be the maximum of the dp table at I comma j, and the sum of previous index block plus the new block in the fruits table. Then we are finally going to return that how much fruits A, B and C will collect. A will calculate the DIHE number of fruits which we have calculated initially. Then B will collect these many fruits at index n minus 1, n minus 1, and similarly C will collect these many fruits at index n minus 1 and n minus 1. But we are going to minus the target block fruits 2 times because we have calculated it for A, B and C all. But we just calculate, but we can only collect it 1 time, so we are going to decrease it for 2 times. So this is the final solution for this particular problem. You can now submit this, and this is going to pass all the test cases for this particular problem. And this is a very efficient solution for this particular problem. You can see the runtime is really good, the memory used is really good. So we have solved this particular problem in a very efficient manner. So if this video helps you to understand the problem and the solution approach, then make sure that you hit that like button. And if you are not subscribed to the channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this video, guys.